Hey guys, so today we're going to find the equation of an ellipse given its major vertices and foci. So when I would be given a problem like this, immediately I would just draw a graph and label all the points we have. We've got 5, 2 is a major vertice. We've got 4, 2 as a focus. We've got negative 2, 2 as another focus. Then our final major vertice is negative 3, 2. So we got something like this. And since we know the major vertices are at these points and the foci are in this line, so we know that x is the major axis. The x direction is the major axis. Direction. And that tells me that, well, the form that we're going to use, it's not going to be x minus k squared. It's not going to be this one, y minus k squared over a squared plus x minus h squared over b squared equals 1, because the a is the major axis length, a is. So we know that that's not in the y direction in this case, it's in the x direction. So it's not this formula, it's actually going to be this one, x minus h squared over a squared plus y minus k squared over b squared equals 1. So that's the first thing we have to do every time. We have to figure out what of the two formulas we're using, because the answers will differ, especially once we start getting into the foci. So we have this, and well, we know that, well, we got to find the center. Okay, so we know that the center is going to be the same distance from either vertice or either foci. So let's just use the foci here and find the point in between the two foci. So we've got 4, 2 and negative 2, 2. So distance from between 4 and negative 2, well, that's 6. So we're going to be 3 away from both points. So 1, 2, 3 puts us at negative 1, 2. And as you can see, that's 3 away from this other one as well. So let's write that as our HK, because that, as you know, is our center. HK is 1, 2. So now we can start modifying this a little bit as we find stuff out. We've got x minus 1 squared over our a squared plus y minus 2 squared over our b squared, all equals 1. And now, well, we know we're going to have to find a squared. And then, well, a is just the half the length of the whole axis, of the whole major axis, and the whole major axis is from major vertice to major vertice. So what we can do is we can take the distance from the center just to that vertice, to either one of the vertices. So if our center is at 1, 2, and we're going to 5, 2, we can see that all we did was we went up 4 in the x direction. Then if we were doing the same thing with the other direction, we could say, well, we went from 1, 2 to negative 3, 2. That's still a distance of 4. So a equals 4. So we write that over here. A equals 4. And then I would say, well, how can we find b? B is the length of the minor axis, so that would be the distance from the center to a minor vertice. And, well, then I would say, well, we don't have minor vertices, so what do we do? The thing is that we have the foci, and the distance from the center to the foci is c. So that is our c value. So let's figure out c, and, well, c is going to be from 1, 2 to 4, 2. That's a 3. So we've got our c equals 3, a equals 4. Then, well, how can we relate them to b? We've got a formula here. C squared equals a squared minus b squared. So that looks like that's what we're going to have to do. We've got, well, c is 3 squared equals a is 4 squared minus b squared, which turns into 9 equals 16 minus b squared, which turns into negative 7 equals negative b squared, which becomes b equals the square root of 7. Okay, so we figured out b and a, and I think we have everything we need to really get this equation. Our final equation, we're going to get x minus 1 squared over a squared, which is 4 squared, which is 16. Not letting me write. 1 second. 16 plus, then we have y minus k, which is negative 2, y minus 2 squared, over b squared, which is square root of 7 squared, is just going to give us a 7, equals our 1. So that is the equation of the ellipse, and we got that from using the major vertices and the foci. I hope that was able to help. Let me know if you have any questions.